Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 8 of GCP's Zero to Hero series, and in this episode, you will learn how to implement a production grade GCP project. So in the previous episodes, we learned about virtual private cloud, what are the various components of virtual private cloud. In today's video, we will put these concepts into practice and understand how a cloud engineer makes use of these concepts in real time. Very simple. Whenever there is a new project within a company, a cloud engineer is expected to set up custom VPC, configure all the components within the VPC so that end user can securely access the application. We will do the same thing, but using a sample Python Flask application. So I have a demo application for today's video through which we will learn everything that a cloud engineer would do. All that you have to do is to make sure you watch this video till the end. This video has 7 steps. I'll first explain the theory part of 7 steps. Then I'll show all those 7 steps using my free tier GCP account. You can also do it on your free tier GCP account. You don't have to pay because everything is covered as part of the free tier. But Abhishek, after watching the video, if I have to implement it on my account, are there any steps that are provided? Yes. You can go to this GitHub repo, go to day 8 folder. I have the complete notes for today's episode. So this README file has again these 7 steps, 1, 2, 3, all the 7 steps, including the source code as well. Perfect. Now, without further delay, let's start with the theory part of the video. What exactly is this video about? Or what is that real-time task? Imagine you are working as a cloud engineer within a company called XYZ, and this company is using Google Cloud Platform. There is a new development team, and this new development team has developed a Python Flask application. Now, for this application, you got a Jira ticket. So your team works on Jira. A Jira ticket is created by this development team, asking you to configure a VPC for the project along with all the components to make their application secure. So this is the only requirement that you got. They haven't elaborated any steps because as a cloud engineer, you need to know how to secure an application within VPC. Now, when you get this ticket, what you would do is step 1, right? So the first step, you will create a VPC. On Google Cloud Platform, when you create a VPC, you don't provide CIDR range. Usually you do it on AWS or Azure, but on GCP, virtual private cloud is spawned across the regions. Depending upon the size of the subnets, the size of the VPC can be estimated. Otherwise, you don't have to provide the CIDR range for the VPC. So, once you create the VPC, as I told, you define subnets within the VPC. Abhishek, how will I know the number of subnets that I have to create? So if there is only one application, or if there is only a simple backend application, you would create 2 subnets primarily. First subnet is called as the app subnet. Now within this subnet, you will deploy the applications. And second subnet is the NAT subnet. So NAT subnet, basically, these applications will be very private. They have to be secure. So if they try to access any third-party application, or if they try to download anything from the internet, it can be Python, it can be Java, or it can be any packages. If they try to download from the internet, their IP address has to be secure, or no information of this application has to be exposed. Because if the information is exposed, if they directly talk to the third-party application, middleman attack can happen. So a hacker can hack the application within the virtual machine. To avoid that, a different subnet is created for NAT, where a NAT gateway, in the world of Google, we call it as a cloud NAT, is created So the virtual machine makes request to the Cloud NAT, or request goes through the Cloud NAT to the internet to download packages, to talk to third-party application, anything it can be. Requests from the private applications or applications within the private virtual machines go to the Cloud NAT, and from Cloud NAT, they interact with the internet. What is the advantage that you would get in this case? Even if there is a middleman attack, or even if a hacker tries to hack a packet, hacker will only know the IP address of the Cloud NAT, not the IP address of the virtual machine. And hacker cannot do anything by knowing the IP address of the Cloud NAT. So this way, Cloud NAT prevents the middleman attack or any kind of hacking. So you will create two subnets within the VPC. Okay. So once you create two subnets, and once you configure the Cloud NAT with all the configuration, then you can go ahead and define the firewall. Why firewall? Firewall is for additional security. Like, even if someone tries to get in through the VPC, somehow, if a hacker tries to get in through the VPC, if the hacker tries to access the virtual machine, the firewall can block the access. Imagine there is a virtual machine, right? This virtual machine has the application as well as the database. Application is hosted on port 80 and database is hosted on port 3306. You can define a firewall and you can only allow access on port 80, not on port 3306. You can also do this with firewall. So anyone, it can be load balancer, it can be a genuine user. So genuine users can access application on port 80. If they try to access database, then the firewall will say, hey, you are not authorized. I will block your access. So every time you create applications or every time you create virtual machines, you should always define firewalls and allow only specific port. In AWS and Azure, you have concepts like ASG, NSG, NACL, but in Google Cloud Platform, you have a single concept, that is firewall. So only firewall can alone handle all the security related to your virtual machines. Perfect. So you created VPC, you created subnets, then you created Cloud NAT, then you created firewall. Now next step is to create instance template. Now what is this? Like, what exactly is an instance template? Very simple. Now when you are dealing with applications in real time, and if you have plans to expose this application securely to the end users, something like Flipkart does, something like Walmart does, something like Amazon.com does, what you have to do is you have to place a load balancer and users will interact with the load balancer. So that if there are 10,000 users as well, load balancer can forward the request to the Python application on multiple virtual machines. You will not create a single virtual machine. Instead, within the app subnet, you will create multiple virtual machines and the load balancer will forward the request to these virtual machines depending upon number of users that are trying to access. I mean, let's take a simple load balancer algorithm. If there are 10,000 users, right, load balancer can forward 5,000 requests to this virtual machine and 5,000 requests to this virtual machine, right? A very basic load balancing algorithm. So this way, Python application on this virtual machine can handle 5,000 users. Python application on this virtual machine can handle 5,000 end users. And all the users will not face any interruption. If all the 10,000 users send requests to a single Python application, it might break. But the problem here is that if you know there are 10,000 users, you can take this approach. But what if, again, companies like Netflix, companies like Hotstar, Amazon, Airbnb, they cannot estimate the load. On a particular day, they might see 10,000 users. On a particular day, they might see 20,000 users. if there is any offer or any sale that is going on, they might also see up to 1 million users. So the load cannot be anticipated. In that cases, cloud engineers go with auto scaling group, or in the world of GCP, we call it as MIG, managed instance group. So with the managed instance group or using managed instance group, cloud engineers can perform auto scaling. We learned in detail about auto scaling in the previous lecture, but just to put it in very simple terms, cloud engineer will create MIG. MIG will decide if there has to be two virtual machines, or when there is huge load, if it has to increase one more virtual machine and make it 3 or make it 4, make it 10, make it 100, right? Or when there is no load, it can also delete the virtual machines and restrict back to two virtual machines. So MIG takes that responsibility of handling the user load, or auto scaling group takes the responsibility of handling the user load. Now, how will auto scaling group know what kind of virtual machine to spin up, what application to deploy on this virtual machine? Because it has to do it in fraction of seconds, or it has to do it in minutes of time. For that, all that cloud engineer does is create an instance template. So instance template is very simple. You will just say what is the configuration of your virtual machine, how many virtual machines that you need, minimum and maximum. That's it. You provide this information to MIG, and MIG will handle everything that is needed. So your life becomes very, very simple with MIG. Finally, as a cloud engineer, you will set up a load balancer, right? And this load balancer will forward the request to the applications or virtual machines created by MIG. This is all what you will do. One more additional step that cloud engineers do in real time is, because load balancer comes with an external IP address, or it comes with a weird DNS name that is particular to Google Cloud Platform. But companies would prefer fancy names like Amazon.com or Walmart.com, whatever their company name is. So what usually cloud engineers do is they go to um, domain name providers like GoDaddy or Hostinger or Namecheap, through which they procure domains like Walmart.com. So once they have this domain, there is a service in GCP which is called Cloud DNS. And within this Cloud DNS, cloud engineers map the name servers so that whenever someone accesses Walmart.com, this Cloud DNS comes into picture and it forwards the request to load balancer. The beauty of this Cloud DNS is, no matter where you are in the world, no matter which browser are you using, whenever you enter Walmart.com, this Cloud DNS comes into picture and it forwards the request to the load balancer. I will also show you this configuration, but there is a catch here. This configuration usually takes up to 48 hours as well. So I'll show you the steps, but it might not reflect as part of this demo. Cool. So now these are the things that we are going to do in today's video. A quick recap and noting down of the 7 steps. Step 1 that we will do is to create a custom VPC. And within the VPC, we will be creating subnet. In fact, subnets. The first subnet is for applications. Second subnet is for the Cloud NAT. Both of them has to be created. Now, once you create the subnets, the second step, we will create NAT properly, right? So we will create a NAT gateway. Here we are only creating a subnet for NAT, but in second step, we will create a NAT gateway within the created subnet. Third step, we will create instance template. My bad. Third step, we will create firewall, as we learned during the theory part as well. Fourth step, we will create instance template with all the configuration related to virtual machine. Fifth step, we will create managed instance group. Sixth step, we will create a load balancer. Seventh step, we will learn how Cloud DNS works. Right? As I told you, I will show you the configuration for this step, but this will take a lot of time to reflect. So you might not see the reflection in today's video. So these are the 7 steps that we are going to learn. Of course, step 8 is to verify. Verify everything is working fine. Now let's head to the Google Cloud platform and implement these steps in action. Cool. So we will first start with creating a project. New project. We will call this as prod VPC, or let's just call it as Python Flask demo. Python Flask demo. We will go with no organization. As I told you, I'm using my free tier account. Of course, I have a billing account, but still, just to make sure everyone can practice it. So we'll be using Python Flask demo project name with no organization. Okay. This should be created in couple of seconds. Perfect. We have the project selected. Let's switch to the project. Now, one thing that I want to highlight here, whenever you're working on such demo applications, once you are done with the demo, go ahead and disable the billing for the project and then delete the project as well, so that you will not incur any cloud costs. Okay. Uh, what is the first step? Let's do the things in the same order. First step is to create the VPC. Cool. So we will search for VPC. If you followed the previous lectures, you must have guessed, to create VPC, we have to enable Compute Engine API, right? Even to create virtual machines, we would need the same API. So let's enable the Compute Engine API. This would take a couple of minutes of time. Okay, so the API is enabled. So we will click on Create VPC Network. I'll just call it as prod VPC. There are two options, custom and automatic. The difference is very simple. If you go with automatic, subnets are created for you. But the catch here is that because VPC spawn across the multiple regions, these are all the subnets that would be created for you. Literally, you will have some 420 subnets that are created for you, which is definitely not needed when you're working on demo applications. So you can choose custom and create subnets as per what we learned here, right? So we'll create an app subnet and NAT subnet at the first place. Okay, till now we provided the name of the VPC. Then we said custom VPC, right? And let's create the subnet here. First subnet. So I'll just call it as subnet or app subnet, as we learned. You have to define a region. Always choose a region that is nearest to you. I will choose Mumbai. Okay. IPv4. We are not going with dual stack or IPv6. I'll stick to IPv4. Provide the range for the subnet. As I told you, you have to provide CIDR range for every subnet that you create. If you're confused what is CIDR, what is these IP addresses, I have made a detailed networking fundamentals video on YouTube. It's a 3-hour long video. If you search for it, you will find it free on YouTube. So you can learn all the networking concepts with that video. I'll try to put the link in the description as well. Going back, so let's choose 10.10.10.0-24. So this means we are creating very less number of IP addresses. Okay, so we have choose the subnet range as well. Perfect. This is all that we need to do for app subnet. Okay, I'm just double checking. Done. Now we will create another subnet, right? Just like app subnet, I will have one more and I will call it as NAT subnet. Great. And we will do the same thing. Region nearest to us. You have to make sure both of them are in the same region. And yeah, IPv4. This time I'll choose the range as 10.10.20.0-24. You have to choose different CIDR for subnets within a same VPC. Okay, all the options are default. Done. Cool. So we have created both of these subnets and we have the firewall rules now. So by default, I'll not select any firewall rules here because I will create my own firewall as part of the next step. So I will only allow SSH access to the instances that will be created in these subnets. Nothing else. I'll keep all of these options same, regional, legacy, and click on the create button. Cool. So we have VPC created along with the subnets. So we are done with step 1. It's that simple. Now we will go with step 2. You have to do step 2 even before you are creating instance, because on the instance that we create, we will be installing Python Flask. So if you keep the instance private, if you don't have the NAT gateway, the downloading of packages will fail. That's why we will create NAT gateway first, only then we will create the instances. Okay, let's see the VPC is created. Cool. It is still getting created. Meanwhile, I will search for Cloud NAT. Okay, so this is the Cloud NAT. It is under networking services. Get started. Yep, in the meanwhile, VPC is also created. I'll provide a name for the gateway. I'll just say NAT gateway, nothing more than that. This has to be public. You know the reason. Network, choose it very clear, right? Prod VPC. Region again has to be Asia South 1. Create a router. I mean, you don't have to provide a lot of configuration in the router. Just provide the name of the router and click on the create button, because rest all are selected, network is selected, region is selected, create. That's all. You will keep this automatic premium, click on the create. Now we are done with step 2 as well. That is, we created NAT gateway also. NAT is running, VPC is also created. What is step 3? Step 3 is to create firewall. You can do all of this configuration once you create the instance as well, but things will become complex if you go in that order. Firewall, let's search for it. Actually, it is also part of the networking services, but anyways, I'll search for it. Click on firewall rule. We will create 2 firewalls in this case. Abhishek, what are these 2 firewalls? Understand this carefully. If we go back to our architecture diagram, so there should be 2 firewalls. Number 1 is for the health check of the load balancer. Every once in a while, load balancer will check if the instance is up, if the application is running within the instance. So for that, there will be a health check, and this health check will run on endpoints like /health, right? So whenever developers write their application, they expose an endpoint called /health. Something like, amazon.com/payments/health. Just I'm giving a very vague example. So load balancer will check every 5 seconds if the application is healthy or not. So for that, we have to create a firewall and allow load balancer to access the application on a port followed by a particular endpoint. In our case, the port is 8080. I'll explain you the application in next couple of minutes, but for now, let's understand that the port of the application is 8080. So we will create the first firewall to allow load balancer, to allow Google to perform health check, right? Now the second step is for the load balancer to forward actual traffic to the application. Now this is not about health check, but traffic that end users are looking for or requests that end users are going to make. So these are the 2 firewalls that we are going to create. Let's start with the first firewall. Allow health check 8080, right? So this is the first one that I'm going to create. Firewall configuration has to be created with utmost care. So make sure you are not missing anything in this step. If you miss anything in this step, your entire project will be, you will mess up with your entire project. Network, always choose the network that we're dealing with, broad VPC. Ingress, so we are setting up firewall for the ingress traffic that is coming to the application. So that's why choose ingress. If it is traffic that is external or application is making to the external world, then you have to choose egress. So I will choose ingress and action is allow. Specified target, no, I want to allow for all the instances in the network. IPv4 range. So this is the range that we are going to select. So this is a constant, these are the constant IP ranges. So when it comes to GCP, you have to provide these ranges. These ranges are for the Google health check. So when you create a load balancer, Google will perform a health check, and these are the IP ranges from where it will perform the health check. So you have to provide them as constant. You can take a note of them. They will be common every time. You don't have to provide any destination filter, but you have to provide the port that is 8080. Perfect. So this is the only thing that you will do, and click on create button. So your first firewall is created. First firewall is for health check. The second firewall is for the application traffic. Create firewall rule. Once I explain you about application, this might become even simple to you. So we will call this as allow proxy only. So basically from the load balancer, we call it proxy because load balancer will only proxy the request. It will not do anything. It will take request from the user and proxy the request to the virtual machine. So that's why I'm calling it as proxy firewall. Okay. So again here, network is prod VPC. Priority we can keep the common, the same one. All the instances within the network, IPv4 ranges. Now this time what has to be the range? The range has to be the range of the load balancer. Basically, a request always comes from the load balancer. So you can provide IP address of the load balancer. But in this case, we haven't created the load balancer yet. So what we can simply do is we can provide 0.0.0.0/0. That means everything from the internet. Once we have created the load balancer, we can just replace this with the IP address of the load balancer. Okay. So for now, let's keep it. Specified protocol, TCP, and port is 8080 as well. Now let's click on the create button. Abhishek, I did not understand, what exactly is this application is doing and why we have created two firewalls. Very simple. So this is our application. Application source code is in step 4. All that we are doing is we are writing a Python Flask application. And this Flask application, when someone access it on /path, it will say hello from Flask on GCP. This is what it returns. But usually developers also build another endpoint in their application. This can be for observability. This can be for health check. That is on /health. So if someone access this application on /path, they will see hello from Flask on GCP. If someone access the same application on /health endpoint, they will see a response called 200 all okay, right? So say they will see a response called okay with HTTP status code 200. So that's why we have created two firewalls. One is to allow this and other is to allow this particular endpoint on the application. Both of them are running on port 8080 only. Cool. Let's see if the firewalls are created. Okay, so we have these firewalls created. One is allow proxy only on prod VPC. Second is allow health checks 8080 that is also on the prod VPC. Okay, so we have both of these health checks also ready. Now, what is step 4? So step 4, according to our theory part, is to create instance template. Now, this is where things start getting serious because we are going to create virtual machine and we are going to deploy our Python application. Okay, so search for instances. This is also part of compute engine itself. So you can search for virtual machines or VM instances. Within the same API, you will find instance template. Click on it. Create instance template. So let's provide a name for the template. If you keep the name same, you can also keep it, but I will just call it as Flask template. Regional, we are dealing with the single region, so I'll keep it as regional. Which region? AP South, that is the Mumbai region. Always go with VM instances that are going to cost you less because you're working on demo projects. Low cost day-to-day computing is E2 series, but within the E2 series, right now $30 is a charge. By making simple changes, one, you can select E2 micro. This goes down drastically up to $8 or something, right from 30, right? And then you can select spot instances. Spot instances are something that can go down anytime, but for your demo projects, it's totally fine, right? You're also using auto scaling group. So even if your instance goes down, another instance will be created. So it came to 4.14 US dollars, which is very cheap for us and great. Now we are not done yet because we have to, you can allow HTTP traffic. In the advanced options, go to networking, and here in the networking, make sure you select the right subnet. So we are on the prod VPC. That is where we want these instances. And in the subnetwork, choose app subnet. And if you remember, developers told this application has to be secure. So what you will do in the external IPv4 addresses, you will say none. So in Google Cloud Platform, this is not a private subnet, but this is how you make a subnet private, or this is how you make instances within a subnet private. Understand this carefully. You have to go to the networking tab, choose the right network, choose the right subnet, and change the external IPv4 addresses to none. So this way, your instance does not get a public IP address. Okay. Now we will get to the management, and within the management, there is a startup script. So in the startup script, you will provide steps to install your Python application and run it as a service. So why are we doing this? So that managed instance group can take care of running these services on the new instance whenever an instance is created. Imagine if you're not providing this script, managed instance group will create a new virtual machine, but that virtual machine will not be of any use. The whole purpose of going with MIG is that whenever there is an unexpected load, MIG will create a new instance, and within that instance, application is also installed. That's why we have written a shell script, and we will provide that shell script here. Very simple shell script. First installing Python packages, then copying the source code into a file and running the source code as part of a Linux service, so that even if the virtual machine goes down, next time it will come up automatically. Right? Whenever the instance is up, this service or your Python Flask application will also run automatically. So I have provided this in the startup script and we are all good now. Scroll down, click on the create button. But at this point, we just created a template, right? We haven't created MIG yet. So the next step, once the template is ready, is to go ahead and create managed instance group. We are almost done. Once we have managed instance group, and once we have the load balancer, we can test our project. Till now, we have done all of these steps, right? So we have created VPC, we have created subnet, NAT gateway, firewall configuration, instance template. Let's go with MIG. I'll search for instance groups. Again, this is part of Compute Engine API. Just scroll down. You will find instance groups. Create instance group. There are two primary options. Do you want to go with stateless or stateful? Stateful is when you're dealing with databases or caching servers. Because I'm dealing with a simple application, I will go with new managed instance group, stateless. I'll just call it as MIG Flask app instance group. Instance template, choose the one that we just created, Flask template. And yeah, it has to be a single zone because I'm not worrying about high availability. If I want this application to be highly available, even if one of the data center goes down, if you want your application to be running, choose multiple zone. Just a single option selection, nothing more. But to keep the cost low, I will select single zone. This is what we learned in the auto scaling group. Say minimum is 2 and maximum is 4. If you want, you can keep maximum as 10 as well. We'll just cross verify. So we provided the name, we provided the instance template, we provided the location, auto scaling. Perfect. Looks like we have provided everything that is needed. So I will just click on the create button. Now within couple of minutes, we will have our applications running within the virtual machine. Before creating the load balancer, we can also test it, but it will take up to 5 minutes of your time. Perfect. So we have the instances created by MIG. Let's get to one of the instance and see if our Python application is running. How do we check that? So these are the VM instances. Let's get to one. If you remember, we enabled SSH access. So that's why we can SSH to these instances. Transferring SSH keys to the VM. We don't need any public key because we are just connecting through the browser itself. Cool. So we are connected. Let's try curl localhost colon 8080. It's okay if you see this error. As I told you, it takes some time because in the script, we are configuring it as a service. So it will take some time even after your virtual machines are running. It has to completely boot and it has to execute your startup script. So wait for it patiently. Maybe you can try it after 5 minutes. You will see that the application is running because the script that I have provided is in the running state. Let's try again. Systemctl status flask.service. Yep. So the flask.service is not running yet. Abhishek, why did you search for Flask service? Because if you see the script, I'm running it as a Flask service. Systemctl enable flask.service. Cool. In the meanwhile, while this is running, let's go ahead and create a load balancer. We'll search for load balancing. We learned the load balancing in the previous lecture as well. We will do exact same steps. First step, create load balancer. Choose the type of the load balancer. Application load balancer. Okay. We are dealing with layer 7 traffic. Whenever you are dealing with HTTP or application level traffic, you have to go with application load balancer. Next, public facing, yes. Do you want a global or regional load balancer? Obviously, we need a regional load balancer. Next, and finally, create a load balancer. In the last lecture, I used global load balancer. Just to make sure you understand, in today's lecture, I'm using regional load balancer. Only additional step, we have to configure proxy-only subnet. I'll do that. Yeah, we will call it LB demo. Because this is regional, make sure you choose the right region. AP South 1, network is prod VPC, reserve and provide a proxy subnet. What are we doing here? We are just providing a subnet. Whenever load balancer receives the request, this load balancer forwards the request to the application. So for this, we are providing a proxy path, or we are providing a subnet. So through this subnet, load balancer will access applications within this app subnet. Because by default, within a VPC, you can allow one subnet to communicate with the other subnet. This is a common practice. We will call it as proxy subnet. And here I will choose 10.10.30.0-24. Proxy subnet will be created. In the meanwhile, let's complete the front-end configuration. Just provide the name to the load balancer. Again, I'll call LB demo. Protocol is HTTP, port is 80, and IP address is ephemeral. That is perfect. So we will keep the things exact same. Front-end configuration is done. Let's move to back-end configuration. Proxy subnet is also created. Front-end configuration is also done. In the backend, we have to create a backend service. Now, what is this backend service? The instance group that you have created, or the MIG that you have created. So we will call this as MIG backend. Yeah, so select the backend type as instance group. Protocol as HTTP. Named port, you can keep it as HTTP. IPv4, create a health check. Now I think things started making sense to you. Why did we create two firewall? Because we have health check and we also have load balancer forwarding the request. So I'll call it demo health check. Protocol is HTTP. What is the port? 8080. And what is the path where the health check will be implemented? /health. Perfect. Every 5 seconds, load balancer, the Google will try to verify the health check using /health endpoint on this particular application. That is on port 8080. So let's select it. Okay. So now health check is created for the load balancer. Now we will select the backend instance type, Asia South 1, IPv4, backend instance type is MIG Flask application. Cool. This is also right. Port numbers is 8080, 8080. Rest all we can keep the same, right? We don't want to mess up with the security policy. We don't want to change anything else. We are all good. So we will just verify the VPC where this load balancer is getting created. Review and finalize. Prod VPC region is good. Backend is also good. Health check is created. Backend is this MIG Flask app. Cool. So we will click on the create button. In the meanwhile, like while the load balancer is getting created, let's try our luck one more time with VM instances. So right, one more time, let's try to log in to the same VM. And this time, let's see if the Flask application is running or not. Okay. So again, I'm taking this browser. Let's see, curl localhost colon 8080. Cool. So we have the response. Hello from Flask on GCP. You can also try curl localhost colon 8080/health. You will see the response as okay, right? So we got the response as okay. You can also verify the final step, systemctl systemctl status flask.service. Cool. So the Flask service is running. Even if you try to delete this instance, stop it, recreate, you will see when the instance is recreated, you have the Flask service running. So that's why I'm running it as a Linux service. Application is always up and running. Okay, it says the load balancer is also created. So let's go with the final check. Search for load balancing. Let's get the IP address of the load balancer. LB demo. This is the IP address. We'll take a new tab. Try it. Tada. So it says hello from Flask on GCP. So what did we do? We implemented this entire thing for the project, right? Now let's try to go in the reverse order. So first we created the VPC. Then we created subnets in the VPC. This one as well as this one. Because we created the NAT subnet in the Python script that we added. So if you carefully watch, in the script, we are installing Flask. Flask is installed from the internet. We are installing Python 3 env. All of these packages are downloaded from the internet, even though your virtual machine is private. That is because we have the virtual machine forwards the request to NAT and NAT talks to the internet. So the secure communication. All the packages that are installed on this virtual machine are through the NAT. So that's why we created subnet. Then we created NAT. Then we created the firewall to make sure only port 8080 is accessed on these instances. If you try to access any other port, you will see firewall will block it. Then we created instance template. We created MIG, which is managing the instances. Finally, we created the load balancer, which is forwarding the request to the application. You can see the magic of MIG. You can try to delete one instance. You will see it will recreate a new instance for you. What is the final step? So you can go to domain providers like GoDaddy. For example, I bought one domain with name Abhishek.Veeramalla.shop. So if I have to integrate this load balancer with this particular domain, so what I need to do, once I have this domain, right? So I have this domain from GoDaddy. I have to go to DNS. So these are the name servers. So I will have to copy these name servers, right? So copy all of them, then go to Cloud DNS on Google. Actually, my website is active somewhere else. So, I cannot even mess up with it. But quickly, I'll show you. Once we enable the API, product details, enable the Cloud DNS API. Now, these APIs are enabled for your billing purpose, just to make sure you understand what exactly are the APIs are you using, what exactly products that are charging you from Google side. So that's why Google has this APIs, which you have to enable explicitly. So you go to Cloud DNS, click on create zone. It has to be public zone. You can provide a name for the zone. Probably you can just say my website. DNS name. What is the DNS name in my case? Abhishek.Veeramalla.shop. Now I got this domain for a very cheap price. So that's why I went for .shop extension. You can get it for, I think, $2 or something per year. And then the 4 DNS names that you copied, you have to paste them here, right? So you can click on create. I mean, I'm not pasting the DNS name servers here because if you do that, it will mess up my somewhere else configuration. But you have to select the type A record and you have to paste those 4 things here. Click on the create. I mean, I'll not do it completely, but once your zone is created, you will find option to update the DNS-A records. So we will get to this. Okay, standard zone details. Let's go here. So we have these name details, right? So we have to edit the source record and we have to update the records that we have copied. So these records should be updated with the records that we got on GoDaddy domain. Once you do it, you have an option to select which IP address you want to map. So provide the IP address of your load balancer. All the steps are provided in the document. If you want to do it, just look at step 7, that is domain setup, how you can buy the domain from GoDaddy, how you can integrate with Cloud DNS. All the steps are provided for you. If you want to try it, you can give it a try and you can validate using your custom DNS as well. But for today's video, I'll stop it here. I hope you enjoyed today's video. Please try to implement it on your free Google Cloud account so that you can master the concepts that you have learned. Especially this is a topic where interviewers also focus on it. Interviewers ask you about VPC, how did you set up VPC, how do you configure the components of VPC. So you can master it by doing this simple 45 minutes project. Thank you so much for supporting. Let me know in the comment section, what do you feel about this project? Are you going to do it? See you all in the next lecture. Take care. Bye bye everyone.